Good morning, you guys. Miss All Day here. Get ready to do 11.5 volumes of Pyramids and Cones. If you would go ahead and get out your notes if you made a copy of them, or if you would go ahead and just get out your spiral composition notebook. Whichever way you are doing it is sufficient for me. All right, so this is going to be a pretty straightforward lesson. We're going to do the volume of a pyramid and we're going to do the volume of a cone. All right, so the volume of a pyramid is 1/3 times the area of the base times the height. So you have to look over at the picture. The area of the base is whatever the bottom is. So you have to do that area, and then you're going to multiply it by the height. But then since you're doing 1/3 of it, you're going to have to divide it by 3. So a lot of the times I'll write it like this. Area of the base times height over 3. Just like whenever we were doing the area of a triangle, we would do 1/2 base times height, or we would do base times height divided by 2. So for this one, we're going to do the area of the base times the height and then divide it by 3. All right. The entrance to the Louvre Museum in Paris, France is a square pyramid that has a height. Let's go ahead and write this out. The height is 21.64 meters. And the side length of the square, it's right there, it is 35.4 meters. So that's the side. What is the approximate volume of the pyramid? So I'm going to write it bigger just in case you can't see it. And remember to pause this as necessary, okay? So volume equals the area of the base times the height divided by 3. So the base is a square. So I'm going to do side squared times the height divided by 3. All right, the side is 35.4 squared. And then the height is 21.64. All right, so first we're going to do 35.4 squared. I'm going to pull up my calculator. 35.4, and I'm going to use the squared button, squared. So that's 1,253.16. All right, we're going to multiply that times the 21.64. So times 21.64 equals, and now I'm going to divide it by 3. And that's 9,039.46. They said the approximate volume, so we're going to round that to just 9,039. All right, so the volume is 9,039. And don't forget, for volume, we do cubic meters. And if you're like, well, why is that? Look over here. You have 2 S's and 1 H. That's a total of 3 variables. Cubic is 3. All right. A sports arena shaped like a pyramid has the base area of 300,000 square feet. Okay, we don't even have to do the area of the base. They just told us what the area of the base is. So let's go ahead and get this going. Area of the base times height divided by 3. So they already told us that the area of the base is 300,000. All right. And the height is 321 feet. So 321 feet. Now notice that the base is square feet. Okay. And when you multiply square feet times feet, that's going to be feet cubed. Just so you know why that happens. All right. And then, of course, we have to add to this the divide by 3. I didn't write that part yet. Now, you could go ahead and do this if you wanted to. 3 goes into 3 once, and 3 goes into 300,000 100,000 times. And then you can multiply the 100,000 times the 321, which means you're going to add 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. So we have 32,100,000 cubic feet will be our volume. All right, so we did the volume of 2 different pyramids. All right, what is the volume in cubic feet of a square pyramid that has the base edges of 40 feet and a slant height of 25 feet? Okay, so what we're looking at here is they already said this is a square. So we're going to do the area of the base. We'll end up doing 40 times 40. That's the easy part. Now, we do not know the height, but we know the slant height, the slant length. So what I want you to do is draw the height from the top to the middle and then draw another leg here. What you just did is you drew the altitude or the height right here, okay, which is actually a leg. And then you drew a leg here. And then this is the hypotenuse. So you can tell what we're going to be using. We're going to be using what? Pythagorean theorem. Because this is a square, you have gone halfway. When you go from this point to this point, you've gone half the distance of 40. So this is 20. So now you have everything you need to figure out what the height is. So I'm going to put h for height, and we're going to do 20 squared plus h squared equals 25 squared. I'm going to subtract 20 squared from both sides. I'm doing it a little bit differently, okay? I'm going to do h squared equals. Now 25 squared is 625 and 20 squared is 400. So 625 minus 400 is 225. The opposite of squaring something is doing the square root of it. So the height is 15. All right, we know the height now. All right, so we're going to go do volume. Volume is the area of the base times the height divided by 3. All right, it's a square. So you're going to do side squared times the height divided by 3. All right, what is the side? 40, right? 40 squared. And what's the height? That's right, 15 divided by 3. Now, I like to cancel, even though I have my calculator. 3 goes once and 3 goes 5 times. So we're going to do 40 squared, and then we're going to times it by 5. So let me pull up my calculator and clear it out. We're going to do 40. Sorry, that is not 40. I'm trying to find my 0. There it is. 40 squared. And we're going to times it by 5. Okay, that's 8,000. All right, so my volume is 8,000. And then always go look at your label. It's going to be cubic feet. So the volume is 8,000 cubic feet. All right, let me erase this part down here. Remember, pause as needed. I'm going to go to the next one. What is the volume of a square pyramid that has the base edges of 24 and a slant height of 13? So I'm going to do a little picture here, a little sketch. This is 24. This is 24. And they told me what the slant height was. Let me show you what they told me here. I'll do it in red. They know what this is. Okay, so they know that the slant height is 13. This is 13. And this is 12. All right, so I went ahead and labeled this slant height was 13. And then the distance from the middle of the square pyramid to the side was 12 because that's half of 24. So if you look at this, you're like, boom, Pythagorean triple. I'm going to put an H here. So the height is actually 5, right? So that's 5, 12, 13. That's Pythagorean triple. If you didn't recognize that, then you could have done H squared plus 12 squared equals 13 squared. And you would still get a Pythagorean triple once you work that out. But since we know that, we're going to move on. All right, so the volume is the area of the base times the height divided by 3. It's a square, so it's side squared times the height divided by 3. The square is 24 inches on each edge. So 24 squared times the height, which is 5, divided by 3. I cannot cancel for this one. All right, so we're going to go do 24 squared. So I'm going to clear this out. 24 squared. And then we're going to multiply that by 5 and then divide it by 3. So times 5 equals, and then divide it by 3 is 960. So the volume is 960, and then it's in meters, right? So cubic meters. All right, so the first two problems was finding the volume of square pyramids when they told you what the height was. For the other two, you had to go find the height by making it into a right triangle and using Pythagorean theorem. All right, so let's move on to a cone. That's the second part of our lesson today. Now, if you look right here, these cones are both slanted. That's called oblique. You're still going to use the same formula that you would for a cone that's called a right cone that stands up straight. So here are the formulas. This is the typical formula we just looked at. To find the volume of a cone, you're going to do 1/3 times the area of the base times the height. Think about a cone. The base is a circle. So you replace the big B with pi r squared. So the second one is the more specific formula that we're going to use. Since I'm doing a cone, I'm going to do 1/3 times the area of the base, which is a circle, pi r squared, times the height. So I like to do this. I like to do pi r squared h divided by 3 because I have to multiply it by 1/3. All right, the covering on a TP rests on poles that come together like concurrent lines. Remember, lines that all meet at a point are called being concurrent. The point of concurrency is where they meet. That's the vertex of the cone. The resulting structure approximates a cone. If the TP is 12 feet high with a base diameter of 14, what is its approximate volume? Now here's a picture of the volume of a cone where you're going to do the area of the base, okay, and then you're going to multiply it by its height. All right, so for this problem, they told us that the height was 12, and we need R. They gave us D. The diameter is 14. So to find R, what do? Right, you divide it by 2. So 14 divided by 2 is what? Right, that's 7. Okay, now we have everything that we need. All right, so we're going to say volume equals, we're going to do pi r, which is 7 squared, times the height, which is 12, and then we're going to divide it by 3. I'm going to make this a little bit bigger so you can see what I'm doing. Pi r squared times the height divided by 3. Now you can cancel the 3 and the 12, but if the 12 was where the 7 was, you can't cancel it yet because that's not what that number is yet. That number is really 49. So it's really pi times 49 times 12 divided by 3. Now I could cancel if I wanted to, but I'm going to cancel the 3 with the 12 and make 4. So 49 times 4. Clear. I'm going to do 49 times 4, which is 196. So this equals 196 pi. Now, it didn't tell us to leave pi as pi. So if it doesn't tell you that, you need to use your pi button in your calculator. Let's see if this calculator has one. I'm going to multiply 196 times pi. There it is, times pi equals. And so it says approximate, so we're going to round that to the nearest whole number. So the 7 makes the 5 round 1 up. So it's going to be 616. So we're going to have 616 cubic feet. So that's the volume of our cone. All right, let's go to the next one. The height and radius of a child's TP are half those of the TP in example 5. So what is the volume of a child's TP to the nearest cubic foot? All right, so what's half of 12 for the height? All right, 6. And what's half of 7 for the radius? All right, 3.5. We're doing the same thing. We're going to do volume equals pi times radius squared, which is 3.5 squared, times the height, which is 6, divided by 3. Now there is a decimal right there. All right, I'm going to go ahead and cancel just to make it simple the 3 and the 6. So when I go to my calculator, I'm going to do 3.5 squared times the 2 because it's no longer a 6. And then I'm going to divide it. Multiply it by pi. So 3.5 squared times 2 multiplied by 5. All right, let me clear this up. 3.5 squared times 2 equals multiplied by pi is. Round it to the nearest whole number. That's 76.96 makes that 77. So the volume is 77 cubic feet. All right, so that's the volume of the child's TP. All right, the volume of the oblique. What is the volume of the oblique cone at the right? Give your answer in terms of pi and also round it to the nearest cubic foot. So they want two different answers. Okay, so we're looking at this and we see that the height is 25. Look at the diameter. We want to know the radius. So what's half of 30? That's right, it's 15. All right, so let's plug that in. Volume equals, I'm going to do 1/3 this time because I don't have a lot of room. Pi r squared is 15 squared, times the height. So we're going to do 15 squared. Go ahead and type that into your calculator. You know that's 225. Multiply the 225 times 25. All right, you got that? And now divide it by 3. All right, you should have got 1,875 pi cubic feet. That's the answer in terms of pi. Now, take the 1,875 and times it by pi and round it to the nearest cubic foot. So that's going to be 5,890. So 5,890 cubic feet. So I'm going to spread my work out a little bit, make it a little bit bigger so you can see. All right, while you're checking that out, let's move on to the next one. What is the volume of the oblique cone at the right in terms of pi and rounded to the nearest cubic meter? All right, so we're always going to go find our variables first. So I'll do this in blue so you know where I'm at. So we're going to do radius. They gave us the radius at 6. We didn't have to figure out the radius. The height is 12. So we're going to do volume equals 1/3 pi radius squared. We can do that in our head, right? 6 squared is 36. And then we're going to times that by 12. Now I'm going to go ahead because I like to cancel, and I'm going to go ahead and change this and do divide by 3 instead of putting the 1/3 there. So you can see this. Divide by 3. I can either cancel the 3 out with the 36 or the 12 because I've already done 6 squared. So I'm not messing with the exponent. I've already done the exponent. So 3 goes 1 and 3 goes 4. 36 times 4. Go ahead and put that in your calculator. That should be 144 pi, and it's cubic meters. All right, so that's leaving pi as pi. And then in your calculator, do 144 times pi and round that. That's going to end up being 452 cubic meters. All right, so those are the two answers that you would have. Now you want to go ahead and check and see what your homework is for tonight and do it. And don't forget to upload your worksheet and do your upload today. All right, good seeing you guys. That's it for today. See you tomorrow. Bye.